Obtain the mesh file and also the full training movie by purchasing this product. The present problem simulates the heat transfer phenomena by a heater inside a room. In fact, the heater is connected to one of the side walls of the room, which acts as a heat source, and its body has a constant thermal flux, and the side walls and ceiling have a thickness of 20 centimeters, made from wood, which has convection heat transfer with the outside. Thus, the ambient air temperature is assumed to be 280 degrees of Kelvin. That shows a cold day in winter, and the convection coefficient is assumed to be equal to 10. The purpose of this study is to investigate the heat transfer rate from the heater to the interior of the room using natural convection and also the buoyancy effect. Therefore, the gravity force is applied to the model. We carry out the present three-dimensional model using Design Modeler software. The present model consists of a room in the shape of rectangular cube with dimension of 4 to 3 to 3 meter and a heater in the shape of rectangular cube with the dimensions of 0.1 meter to 0.8 meter to 0.5 meter in its interior, which is connected to one of the room's side walls. And also the meshing of room and the heater is done using ANSYS meshing software, and the mesh type is also structured. And also the gravity effect on the fluid is equal to minus 9.81 along the z-axis. From the scale mesh section, we can display and check the dimensions in all three directions and also view the length unit that is in meter in the CFD simulation. As we are going to investigate the heat transfer by the heater inside the room, so it's obvious that the energy equation should be activated. As we mentioned before, the air should assume to be as an ideal gas. Also, this heater acts as a heat source in the room, and we can identify the magnitude of the heat flux. You can use the residual monitors dialog box to control the residual information that Fluent software reports. In the equations section, the residual option indicates the name of each variable for which residual information is available. And the monitor indicates whether or not the residuals for each variable are to be monitored. You can toggle monitoring on and off for each variable by turning the corresponding checkbox in the monitor list on or off. The check convergence option indicates whether or not the convergence of each variable is to be monitored. If convergence is being monitored, the solution will stop automatically when each variable meets its specified convergence criterion. You can check convergence only for variables for which you are monitoring residuals. You can toggle convergence checking on and off for each variable by turning the corresponding checkbox in the check convergent list on or off. And finally, the absolute criteria or relative criteria shows the residual value for which the solution of each variable will be considered to be converged. To set this value manually, enter the new value in the corresponding absolute criteria field. And that's it. At the first step, we should make a plane that we are going to show all the two-dimensional contours and that. So the best plane in this computational domain should pass and cut the heater from the middle. The room dimension in the y direction is from minus 1.5 meter to 1.5 meters. So the central plane would be 0 as the ISO value. A summary of the defining steps of the problem and its solution is given in these tables. Obtain the mesh file and also the full training movie by purchasing this product. To benefit from MR-CFD services including simulation, consultation and training, contact our experts via info@mrcfd.com.